Conor is the managing director of Illig, the North American subsidiary of Illig, a Germany-based designer and manufacturer of thermoforming, tooling, and packaging systems. Conor is a member of SPE since 2000 and serves as editor for the SPE Thermoforming and Recycling Division publications. Conor has contributed articles on plastics and sustainability for international industry press in the US, Europe, and Asia. In 2017, he was elected to the SPE Executive Board as Vice President of Marketing and Communications, and re-elected in 2020 as the first VP of Sustainability. He is the co-author of the forthcoming second edition of Plastics and Sustainability, Gray is the New Green, published by Wiley and Scrivener. Conor has degrees from Boston University and from F.W. Olin Graduate School of Business at Babson College. I welcome Conor and appreciate him taking the time to give us his talk today, One Man's Trash. So Conor, I'll turn it over to you.
Great, Paul, thanks very much, and good morning and good afternoon, good evening for listeners all around the world. So I got to figure out a way to shorten that bio a little bit and kind of get down to business here, but I appreciate the introduction, Paul. I'm going to share my screen and we'll just jump right into it. All right, very good. So good morning from Boston, Massachusetts. Today's presentation is going to examine plastics and sustainability and whether or not this is a contradiction in terms. So perhaps most people are familiar with the expression that one man's rubbish or one man's trash or garbage is another man's treasure, but we're going to explore it and see if this can be applied to the world of polymer-based materials. All right, let's get, okay. So for the agenda today, we're going to proceed with a short introduction about myself and role within the SPE, although Paul covered that adequately. Then we'll proceed for some context for the discussion, one that we're all familiar with, but I'll also introduce some definitions so that we have a shared language throughout the slides. From there, I'll talk about what makes a package sustainable or not, and we'll examine some very thorny topics, and then we'll handle some Q&A through the chat box at the end. Now, so why am I the one talking to you about sustainability? My introduction to it came about through a book called The Ecology of Commerce by a writer and environmentalist called Paul Hawken. And in short, he explained that industrial cycles don't typically match natural ones, but that if we harness the innovation and entrepreneurship of human ingenuity, use nature as our North Star, that we might be able to rectify some of our worst environmental decisions. In additional writings, he stated that natural capital must be defined, developed, and integrated into economic thinking. So throughout my time at business school, I was heavily involved with business plans, sustainability curriculum development, consulting for biofuels, wastewater, and energy management companies. But because I started my career in plastics, I ultimately returned to learn to apply what I learned into this dynamic industry. So as Paul mentioned, I've been with SP for coming up on 20 years, and I'm very excited about this new role of sustainability. Now, pollution of any type represents ecological and environmental problems. What we want to do today is explore whether the current focus on plastics is fully warranted. Now, there are many in the plastics industry that are aggressively pushing back on the dominant narrative that we're drowning in plastics, that turtles are dying, and therefore plastics are bad and should be banned. Now, engineers like data where narratives don't matter so much, but regular folks are very susceptible to compelling narratives. Now, will there really be more plastics than fish in the sea, as we've seen from some of these memes and reports? But given the difficulties in measuring both, it seems like a lazy projection at best, and in fact, it has been debunked. Now, are we really drowning in plastics? Or should we be so focused on plastic instead of other materials that have much bigger environmental footprints? For example, things like munitions dumped at sea, abandoned fishing nets, concrete production and disposal, etc. Has anyone read about the energy requirements of Bitcoin? This has been in the news quite a bit lately. If Bitcoin was a country, its electrical consumption would rank between Ukraine, number 27, and Sweden, number 29. And just to confuse things further, gold mining is 50 times more expensive than Bitcoin mining. And that's before we talk about the very physical, very environmentally polluting byproducts of gold, or in fact, any other type of mining. So it wouldn't be a conversation about plastic and sustainability if we didn't talk about the turtles. So my colleague, Christy Armit, has spent a significant amount of time and resources to examine the data behind some of these memes that we see on the internet. We all remember the image of the turtle with something in its nose. Turns out it actually wasn't a plastic straw. But when you look at the long-term research and the data that comes with it, you'll find that reducing your shrimp consumption will do a lot more for the turtles than declining a plastic straw at your local diner. Now, the image on the lower right here, by the way, is used in a company presentation to promote the use of water-soluble plastic bags. But if you look closely, it's clearly a fabricated or photoshopped image to make a point. But this is the type of information that must be challenged by the people who care about facts. So let's rethink plastics among ourselves for a moment, at least in terms of how the public thinks about it. And the average citizen is bombarded with messaging and information 24/7. Our brains are not designed to interpret all of this information, so we manage according to our own abilities, interests, and time. Those who specialize in a particular area will be able to better interpret that subject matter. A polymer scientist and an airline pilot might both enjoy baseball, for example, but they probably won't be interested in the minutiae of each other's daily tasks. Now, when the news media or social media present information about plastics, it typically relates to litter, marine pollution, and/or the risks of ecotoxicity. But we can safely assume that the percentage of organic chemists in any given population is rather small, perhaps 1% or less. So what do people do when they see images and hear stories about environmental degradation at the hands of plastics, so to speak? They assume plastics are bad. They assume nature is good and that it should be preserved, that this is reasonable. No one wants to destroy the environment or biodiversity. But a closer look at some of these reports revealed troubling findings. Several high-profile reports have been repeated without critical or peer review. Many of the common assumptions we hear about are based on bad research, inaccurate data, and in at least one case, just outright fraud. But science and chemistry are difficult. Science evolves and changes. When people want to know if PET bottles, for example, are BPA-free, should processors stamp the bottles with BPA-free, even though it was never there to begin with? Would people still eat cabbage if it contained a list of the chemicals used in the production thereof? But there's no argument that the production of plastics is far outstripping our ability to recycle it. In both quantity and complexity, as we'll see later, too much plastics is simply not being recycled. A global estimate suggests that only 9% of all plastics ever made was recycled. There are many reasons for this, including underdeveloped markets and a lack of investment in the correct infrastructure. Some of this is being addressed, but the progress is slow. In the meantime, humanity burns, buries, and litters still a lot of material, not just plastics though. Now, oil and natural gas, fossil-based feedstocks from which most plastics are derived, are global commodities traded on world markets, and the prices are therefore volatile. But recycling markets are decidedly local. And now that China's national sword ban has exposed serious deficiencies in many of these markets, it is incumbent on local players to develop homegrown solutions to waste management. And some countries are doing this better than others. And though there are several success stories, there are many failures. Is this just an example of creative destruction that we see? After all, many businesses fail. Are we too close to this to see it objectively? From the perspective of private investment, this is a risky business. The majority of private equity funds in the plastics sector tend to flow toward bolt-on acquisitions of producer companies. In Europe, there have been some notable acquisitions whereby resin companies have purchased recycling companies, and that's been used as a strategy to secure post-consumer material. Perhaps this is a model that will be copied by others. But the future is not condemned to look like the past. And what if virgin feedstock was not so cheap and plentiful? And what if the demand increases for recycled materials and drives investment on the supply side? And what if local or regional governments sponsor plans to build local infrastructure to create jobs and develop many mini circular economies? But we have to be honest about the challenges that we face as societies. Sometimes events move faster than our ability to respond to them. And even though China announced the national sword policy in advance, many Western countries were still unprepared for the massive disruption that ensued. Oil prices are rising again, and stocks of fossil fuel companies are outperforming newer clean tech companies such as wind and solar producers. Now, efficiency is usually considered beneficial. Doing more with less is a good way to manage resources. But what happens when efficiency inspires increased use of an item? In the energy world, the Jevons paradox is a term used to describe the phenomenon whereby a commodity is made more efficiently, but demand for the item continues to rise, leading to increased consumption. According to the head of packaging innovation at global athletic wear company Puma, 100,000 items are packaged per second globally. Now, the speed of packaging innovation far outpaces the ability of the recycling infrastructure to manage it, even in areas where the investments and the policies align. That's perhaps a truism of media in the modern age that negative news is somehow more appealing or gets more coverage. But a closer look at innovation in plastics recycling and bioplastics reveal a rich array of entrepreneurs and small companies who are working to solve difficult problems. And just because things have been done a certain way until now doesn't mean that it will always be so. I encourage everyone to subscribe to the newsletters of startups, find the online conversations where the entrepreneurs are seeking help with scale, scientific and technical advice and investments, and watch out for strategic investments and financial investments in new technologies to see where the future lies. Should we expect any less of entrepreneurs in the plastics and packaging industries? So how do we start? So I'm going to suggest one possible way is to look at plastic packaging in a holistic, systemic manner. Now, form and function are arguably still the twin pillars of design success, and they must remain important. But designers are starting to look farther afield to consider the long-term impacts. Design for environment, or DFE, is pivotal to creating sustainable products and packages, yet it is not widely taught. So if we look at the chart here and we go around from the top left in clockwise, we'll go through a few of these points individually. Now, resource efficiency. In general, how do we do more with less? But if we do, as we just saw, will we create a type of Jevons paradox? Non-fossil resources. Now, is a bio-based option preferable given the form and function of as part of the question? Do we understand the end-of-life considerations of bio-based materials? And we'll look a little bit more closely at a comparative analysis among PLA, polypropylene, and PET for coffee for single-serve cups in just a minute here. Now, the LCA score, though they're not without challenges, LCAs can offer data that can be used when measuring the environmental impact of two different material options. Bio-based materials typically have a very high water consumption compared to conventional or fossil-based materials, and this impacts their score. And then EOL, or end of life. This has perhaps been lacking in design considerations until recently. If an item is easily recycled within a given infrastructure, is it the best option, even if it's a fossil-based material? Scorecards, spider charts, Venn diagrams, tables, weighted averages, et cetera, et cetera. There are many ways to measure sustainability, but can we unlock a universal standard? I recently read that biodegradability is highly sensitive to local soil conditions, as you would expect, but for colder countries where soil temperatures rarely reach the requirements for biodegradability, the question arises, why should this path be chosen if the environment itself does not offer compatibility? So this table here is a summary of a recently published LCA report. And it summarizes the findings that sought to compare PLA, PET, and PP single-use cups. Now, there were 13 impact categories originally selected, and they're copied here along with their functional units, as we can see, and that's what allows comparisons in LCAs. Now, the authors did acknowledge there were some difficulties in assessing comparative data, so only 6 impact categories were ultimately measured and compared. The conclusion of the study states that in the current context of infrastructure and material production, transportation, and all the other boundary conditions that they had set, that the polypropylene cups outperform PET in all 6 categories, and they also outperform PLA in 4 categories. Low weight and low density of propylene are the biggest contributing factors to this. The lack of appropriate infrastructure for PLA, whether recycled or composted, is the single biggest reason for the lower score of the bio-based material. Although process heat and electricity consumption from converting the biomass to PLA also contributes to a higher climate change score for PLA. Now, at its core, sustainability means that we today cannot compromise the ability of the future to sustain themselves. The Native American tribe, the Iroquois, lived by the 7th generation principle and stated as follows: in our every deliberation, we must consider the impact of our decisions on the next 7 generations. Now, ironically, perhaps the name given to this principle has been adapted and adopted by a consumer products company recently acquired by Unilever, but I digress. The core of plastics and sustainability, therefore, is the measurement of the impact of our material choices on the environment. If everything is equally important, then nothing is important. Yet we must work with what we have and develop new tools to assess, measure, and manage our choices. So the next few slides are designed to stimulate some questions and debate among designers, marketers, engineers, and processors. And though there are standards bodies such as ASTM and ISO are working to create universal definitions in certain areas, such as ASTM, D20, and plastics, it remains true that most companies make their own decisions regarding their design choices. But if we ask what makes a package sustainable, here are some items to consider at the outset. So as previously noted, to form and function, we must add end of life. Polymer-based materials are incredibly flexible and efficient, and they can be tailored almost infinitely to meet discrete specifications. This makes it difficult for a designer to be aware of all the possibilities. Lightweight materials are more efficient to manufacture and transport, yet in a recycling context, greater volumes are required to achieve similar levels of mass, on which some price models are based. And a lively debate is now underway about what is recyclable in theory versus what can actually be recycled in reality. Policymakers are taking note and creating new rules and regulations in this area, with some fines and punishments being handed out. But if no one makes any money, no one's going to bother to do this work. Government subsidies and extended producer responsibility programs are 2 options that can underpin or support an industry, but so far they've only been applied in some limited cases. Now, one can make the argument, however, that if producers were to engage in EPR or deposit schemes, those funds could be used directly to create the necessary programs for end-of-life management. Now, these design decisions are not made in a vacuum, however. Like a kaleidoscope, the perspective changes depending on who is looking through the lens. And we have the entire plastics and waste supply chains that are connected, but they're perhaps not working in concert just yet. We have industry and the consuming public and their government representatives, 2 of which pay taxes and 1 of which spends them. This is a thorny area that we're not going to be able to cover today. And then we have the environment. They're represented by whom? Mother Nature. We haven't spoken too much about externalities yet, but these are the costs that society pays, and they're not reflected in the price of a good or service. The environment, via planetary carrying costs, tends to pick up the bill for us here, but even Mother Nature has limits to her generosity. And the move toward flexible packaging has created an entirely new class of materials. Now, in Japan, for example, fees on package weights have led to an increase in the volume of plastics produced, even though the overall weights have gone down. And this is thanks to novel lightweight barrier materials. In France, companies are awarded bonus points for packages that allow recyclability. They're also charged malus points for heavy or incompatible packaging materials. The pros and cons for a new package design, a flexible drinks pouch, are spelled out here. Now, companies like Dow Chemical and others in the polyethylene supply chain have been working to develop monolayer materials that provide the same shelf life benefits as multi-layer construction materials. These are now being referred to as recycle-ready materials. And when done correctly, this can result in simplification. The removal of metallized films and nylons helps enormously with end-of-life management, and the performance is not compromised. Now, costs remain a question because, as we saw with the Jevons paradox, highly efficient and optimized systems greatly reduce package costs. Now, in terms of recycling, we can categorize processes as mechanical or physical or chemical. Advanced recycling can include both processes, yet most people tend to think of the first generation mechanical recycling, grinding and washing plastics, then re-extruding it for new applications. New developments in physical recycling include dissolution, whereby materials are treated with solvents to separate and purify multi-layer materials. Chemical recycling or molecular recycling is defined as breaking apart or unzipping the molecular structure of a polymer before repolymerizing it for plastics, or synthesizing the molecules for other uses, including the creation of synthetic gases. So over the course of the past decade, and rapidly so during the past 5 years, in fact, several high-profile developments in advanced recycling have piqued the interest of the plastics industry and the public at large. But as with any new, fast-moving and dynamic market, one can only provide a snapshot at a given point in time, synthesizing and summarizing the current literature and offering some guarded prognostications for the future. And advancing recycling has champions and detractors. Skeptics say that large chemicals firms are publishing information and pushing new and unproven technologies as a smokescreen to give continued license to produce cheap fossil-based plastics. Others say that the displacement of virgin materials has a net benefit in terms of GHG reduction. And to provoke things even further, what's so bad about a well-managed landfill after all? Many engineers and chemists will point out that plastic waste remains inert in landfill with no degradation and no emissions. But it's not easy to be comfortable with ambiguity. And sometimes we have to accept that solutions to complex problems are difficult, messy, and incomplete. But we cannot let the perfect be the enemy of the good when it comes to environmental impact. Sometimes the least worst option is simply the best choice. So a final word then on externalities. Free market economists like to praise the efficiency of markets to allocate resources and set prices through supply and demand. The theories of Milton Friedman have driven shareholder value primacy for decades. Recent years, however, have seen a dramatic change in thinking among influential leaders around the world. There is no free lunch, and consumers have a role to play in the expectation that prices will go up for certain items where externalities must be priced in. This is not a net negative, however. Smart policy and certain types of intervention can lead to innovation and new job creation. Profits and purpose can go hand in hand. Like Paul Hawken and the other environmentalists have shown, the triple bottom line of people, planet, and profits is truly the best path forward. And it can be done, and it must be done. And we, members of the plastics industry, have an important role to play. With that, we'll wrap up and see if there are any questions to take. Paul, I'll turn it back over to you, and I can hold my screen here or I can stop the share.
Okay, great, Conor. Thanks very much. Very, very good presentation. Just a reminder, if there are any questions, feel free to populate in the Q&A spot at the bottom of your screen. Currently, I have no questions in the chat, but I'll ask one. So, in your role, with SPE as VP of Sustainability, how is SPE, looking at this, and what are some of the things that SPE is doing, as far as promoting plastics or really addressing that concern?
Yeah, good question, Paul. So, I mean, there's a couple of ways to look at it. I mean, the first thing that I often say is that we have to recognize that SPE is a community of individuals, right? SPE is not a lobbying group. We don't have offices in DC. We're not involved in legislation. So really, the question has to be asked of every one of us. What are we doing? At the board level, however, when we made this role a position on the executive board, the role there is to serve as an advisor to the organization, right? Which topics in the world of sustainability are relevant, which ones are relevant to what SPE can do, such as participating with other groups around the world. So, for example, SPE is now going to be working with a global group to develop a series of recycling and circular economy conferences around the world. This is known as RACE. This is going to be held in Asia, in the Americas, and in Europe over the course of the next year, and we'll see some more information on that. We've developed a series of sustainability topics, as webinars or as individual talks within other TopCons, for example. Next week, we're actually going to be featuring a unique startup company called Obago. This is a guy local here in Massachusetts who spent years trying to get ways for people to take their shopping bags. And he's developed a system to make them into pucks so that they're going to be accessible in recycling programs curbside. So, you could really go to a sustainability conference almost every day, it seems. Our job here is to try and figure out which ones, where can SP be most effective by thinking solely about, an objective, scientific and data-driven approach to plastics and polymers in a sustainability context. And I think we actually do a good job there. There's a lot of specialists in SP's ranks, but really fundamentally it comes down to everybody, getting online themselves, challenging some of these misperceptions and promoting the good works that plastics are doing.
Excellent. A couple questions coming in. So do you see mechanical recycling and chemical recycling or advanced recycling both being needed to solve our recycling issue, or would/should one form of recycling be favored over another?
I think it's too early to favor anything, and really then you kind of get down to who does the favoring, so to speak, right? I mean, we're still operating in a free market, so there's a lot of competition of different technologies that are coming in. Some of the larger resin companies are investing heavily to find solutions for elements of their own value chain that I think are relevant. But mechanical recycling has been around for a long time, and there's a lot of advances in that as well. So I'd say for the moment, it's certainly going to be an all of the above approach.
Great. Here's another one. So can you comment on any differences or similarities that you see between regional responses to governmental policy and or sustainability goals? For example, are different regions working with different priorities?
Absolutely. I mean, you look at, the two biggest ones, maybe the easiest comparison between the US and the European Union, for example, right? The EU tends to legislate and regulate a lot more than we do in the States. And even though the EU is made up of 27 member countries, what gets issued from Brussels as the European capital there tends to be implemented in the individual countries, even though they also have some competing and conflicting issues over there. In the States here, for one example is that of the resin identification codes, only 39 states have adopted that still in the US. So there's 11 states around the country that don't see the need to use resin identification codes, even though I think in practice, these things are spread out and you get there. But regionally in the States, I think there's some great examples in California, for example, where they are using a good mixture of legislation and incentives to do things like separate thermoforms, PET thermoforms from PET bottles and create two distinct streams, because the thermoforms typically have a lower IV than the bottles. And so the bottle grade maintains a premium price, but the thermoforming grade are now going back into their own ecosystem where they're being used by people like Driscoll's, people who are doing a lot of packaging in the berry business out there with big agricultural interest in California. So there's definitely a lot of regionalization here.
Excellent. I've got a couple more. So is there good rationale for bio-based and biodegradable plastics? They seem to have poor thermal stability for compounding reclaim.
Yeah, this is tough. They haven't been around as long as other polymers at commercial scale, right? So part of me suggests that we need to, be a little bit more patient. There's plenty of polymers that have, different degrees of properties that make them, better or less suited to certain environments, right? Propylene has a lot of advantage, but typically needs to have a layer of EVOH or something else compounded in it to help with, long shelf life in food packaging, for example. But the bio-based ones, there's like the report I had mentioned there on the impact scores. There needs to be a lot of development on the ecosystem to allow them to really, exploit their full value, right? Coming from nature and going back to nature, there's a strong sort of compelling reason why we should want that to work. but we have to be careful about wanting something that may or may not be practical, right? And I think in certain environments, PLAs, for example, or even PHAs, will lend themselves to it, but it's not going to be a one size fits all. I think it's going to be very regionalized.
Can you comment on proven most effective and energy efficient methods for plastic recycling and corresponding targeted materials?
So interestingly enough, we had a 2-part series on energy efficiency for plastics processing. It wasn't specific to recycling, but there was a company called Cascade Energy, and both of their talks are in the SP YouTube channel. You could look at those now. They went through a lot of very specific items in terms of how people really need to manage their energy consumption, right? This is things like variable frequency drives, checking for air leaks, some very basic treasure hunt type ideas that are associated with some Japanese best practices from Kaizen, from automotive manufacturing years ago. So a lot of those are still very applicable. In terms of corresponding targeted materials, I think maybe what the questioner is asking is, should certain materials be used for one particular recycling method as opposed to another? And I think we're starting to see that with the advent of a lot of these advanced recycling ones, especially for the flexible films, and even for shopping bags and things like that. So I think it depends. I think it's regional. It's going to depend on the makeup of the parts as to which technology is going to be the best for the particular waste stream.
Excellent. I have a question here. Several recycling centers in my area have closed due to high cost to recycle and limited value in the recycled materials. What can SPE do to promote plastics recycling to show the material value? Area plastic companies are recycling only post-industrial sources.
Yeah, this is a tough one. Again, what can SPE do? I mean, I think SPE does plenty already by giving people, platforms for knowledge and networking, right? I mean, we have a distinct plastics recycling division. A lot of people from the Detroit area, have populated that group. I can recall a few parts that were displayed at Antec a few years ago, that were more greater than 50% recycled plastic in some of these critical components in the automotive sector, for example. I think more people should join that division, frankly, and learn more, share ideas, and then take it back out. The broader question about the economics, about showing the value, is just tough, because the market is not adequately assigning the costs, like I mentioned, in the externalities to this, where the when virgin plastic is cheap, recycled materials just won't compete on an open market basis. And now with resin prices going up again, it'll be interesting to see if there's a change in the dynamics of the recycled plastics industry.
Yeah, I agree. This is a good question. So what can you suggest to a resin producer beginning to participate in sustainability efforts? Where can they start? What R&D efforts should be focused on?
I think a lot of the big resin producers have already done a lot of work in this area, right? And frankly, bigger companies tend to have more resources that they can put on this. And there's a couple of different ways. People who are developing novel resins based on different chemistry, for example, that reduces the environmental footprint or the energy required, is a big one. But even looking at company sustainability reports that are already out there, I mean, a lot of this stuff is mapped out for people. Sustainability is, can be classified as either corporate social responsibility, which encompasses a lot of it. And now we're seeing more of the focus on ESG, environmental, social, and governance efforts. But a lot of these are sort of linked from, if you go back 30 years when people were talking about particular types of cost cutting, environmental health and safety, then corporate social responsibility, and now perhaps into ESG. There's many companies that have done this, and I would suggest taking a look. I mean, a great one I read recently was from Berry Plastics, or Berry Global, as it turns out. They have a lot of very detailed information in there about getting the right metrics and the right scores to report up into these global reporting initiatives at GRI, for example. So, I would suggest looking at those first. Not everybody is going to be at the same scale and size as a company like Barry Global or Sabic or others like that, but they can certainly start there and look to develop their own roadmap.
Great. Do you see any modifications or future changes on how we identify biodegradable, biocompostable plastics standards? Do you see a possible joint standard between different markets, Europe, Asia, Americas?
I have to confess to being a little pessimistic on this one. We actually had Kelvin Okamoto, an SP member and a consultant who's on the ASTM D20 boards, where he's heavily involved in development of these standards for plastics. It's all voluntary, right? There's absolutely no mandates in this. It strikes me that these boards are really trying to do good work, but it's very, very difficult to get buy-in voluntarily from a lot of companies. So it is an area of specialization. I know there's some divergence between some of the things that are happening in Europe versus here in terms of definitions and classifications. I can't claim to be an expert in that field myself, but again, if we go back to the SP YouTube channel and we look for that Kelvin Okamoto webinar, he actually does go into it in some detail, and he would be a good resource for that. But to answer it directly, I don't see a joint standard at this point, especially if you bring in 3 regions. It would be one thing, between North America and Europe, where arguably there's some, cultural consensus on some of these things. But Asia is huge. I mean, this is, you've got a lot of different areas in Asia too, between China and Japan, Southeast Asia and India. They may not even want to bother talking to us, frankly, and they could figure it out themselves for something that's going to be relevant and important to what's happening in that part of the world.
Fantastic. We do have time for any more questions. If there are any, feel free to pop them into the Q&A section.
Yeah, we can always follow up afterwards, start a discussion on the communities. But again, the single biggest takeaway is that, again, SP is individuals, right? SP is not an entity that's going to do something on behalf of people unless they choose to do it themselves as a group, right? Whether it's, divisions hosting technical conferences to get new information, or whether it's geographic sections partnering with somebody to, something as simple as a beach cleanup, or, get the SP Foundation, which has a sustainability module, to go to schools and start helping to promote this. So I think there's a lot we can do, but we have to roll up our sleeves and do it as volunteers.
So there is a question on what initiatives can be taken towards sustainable waste management for filled plastic scrap? Well,
the first thing is to separate it, right? If it doesn't have any value, no one's going to want to do anything about it. That's what it comes down to. So, unless we're in some closed loop system or take back programs, that's definitely tricky. I mean, that gets back to design for environment right at the outset. Why is the plastic filled? If it's just, for economic reasons, or is it for barrier properties, or for some other benefit to the user? That really has to be examined first of all, to see if it can be done in a better way. In the book coming up, there's 12 steps of green chemistry, and the first few of them relate to really trying to simplify materials so that they can be more easily taken apart or taken back or recycled without having to worry about things that are just going to be very, very difficult to manage at the end of life.
All right, Conor, thanks again. Really appreciate it. Great presentation.